Hello everyone, thank you for joining my presentation. Today I will be discussing the influence of various FRP reinforcement types and concrete strength on the structural behavior of flexural members. My name is Shahir Ahmad Safi and I am presenting on behalf of my co-authors Muhammad Abbas Ali, Raza Tufail Hussain, Raza, Bilal Masood and Arshad. This research is being presented at the third International Conference on Frontiers in Academic Research happening on June 15 to 16, 2024. Well, concrete is a fundamental material in construction due to its excellent compressive strength and versatility. However, it has a significant drawback, its low tensile strength, which makes it prone to cracking under tension. Traditional reinforcement with steel bars helps mitigate these issues, but comes with its own problems such as corrosion and added weight. To address these challenges, fiber reinforcement polymer or FRP composites offer promising alternatives. They have a high strength to weight ratio and are resistant to corrosion. The primary objective of our research was to investigate how different types of FRP bars affect the flexural behavior of hybrid beams. Specifically, we aimed to assess how various fiber types impact the structural performance of concrete. We compared the effectivenesses of carbon, aramid, glass, basalt, and steel fibers in improving the flexural strength of concrete beams. So in our study, we used several types of reinforcements. These included GFRP box profiles and FRP bars made from carbon, aramid, glass, basalt, and steel. The concrete mix had a target compressive strength of 37 megapascal. We also incorporated different fibers into the concrete, which were steel fibers, glass fibers, and polypropylene fibers. We cast hybrid beams with various combinations of these FRP bars and fibers to evaluate their performance. So the specimens were used for their flexural strengths using a machine with 50 kilonewton capacity. The beams measuring 500 mm in length and 75 4 mm and cross sections were placed on supports 400 mm apart. So we applied the load at the center to create bending. Each specimen included different combinations of reinforcing bars and fibers in the concrete matrix. Let's look at the details of our experimental setup. The dimensions of the specimens were 500 mm long with a cross section of 75 4 millimeters. We placed the reinforcing bars in the tensile region of beams. During the test, the load was applied at the speed of 2 mm per minute. Well, in a result, as you can see, here are the results for load deflection behavior. For non-fiber specimen, the RH specimens showed a linear response reaching a maximum load of 20.5 kN. The RH-FRP specimens had reduced stiffness but reached a maximum load of 22.5 kN. For polypropylene fiber specimens, PGFRP achieved 24.5 kN, although with decreased stiffness, while PHCFRP had the highest stiffness among them, with a maximum load of 26 kN. When we examined the impact of different fiber types, we found that GHWR displayed a linear response with a maximum load of 19 kN. GHCFRP achieved the highest load among glass fiber specimens, reaching 32.1 kN. The SHGFRP specimens followed a linear load deflection pattern and reached 32.5 kN. The specimen's reinforcement reinforced with steel bars. SH steel bars demonstrated the highest stiffness and strength with a maximum load of 34.5 kN. In our discussion, we observed that specimens reinforced with steel bars and CFRP bars exhibited the highest flexural strengths, including steel fibers in the concrete, significantly improved its flexural strength, showing a 57.5 increase compared to non-fiber specimens. In contrast, polypropylene fibers had a minimal impact on the flexural strength of the beams. To conclude, our research shows that CFRP bars and steel fibers are highly effective in enhancing the flexural strength of concrete beams. Hybrid beams with FRP reinforcement can effectively overcome the limitations of traditional steel reinforced concrete. For future work, we plan to investigate the long-term durability and performance of these hybrid beams in various environmental conditions. Additionally, we will explore the environmental impact and cost-effectiveness of using FRP composites in constructions to assess their sustainability. Thank you for your attention. I will be happy to answer any questions you may have about our research. Please feel free to ask.